This is a video to explore the Newton's Method app. So when you turn on the Newton's Method app, it will give you this first graph, 4 cosine of x minus x cubed plus 3x, and a guess of 0. So to explore Newton's method, we can first just hit submit. So let's do that. And we can watch Newton's method happen. So notice the first guess was 0, the second is negative 1.33, etc. And then it goes to negative 0.89, all the way down. And notice it starts staying the same at negative 1.04933991. And that looks like about the root. One thing about this is that it's hard to see exactly what's going on because we want to change our window. So let's change our window, and there's a few ways of doing it. One way is I can click on Z-box, and then I can make a box around the interesting part. So I click, and I'm going to drag, and make a box around the interesting part of the graph. And if I let go, it'll show that part of the graph. And if I hit submit again, we can really see what's happening with Newton's method. So notice that our first guess was here, and it creates a tangent line, sees where that tangent line hits the x-axis, finds a point on the curve with that x value, and then creates a new tangent line at that point, and then continues on. I can also hit my zoom in button, or Z in, and what that will do is it will zoom in on the point at which it crosses the x-axis. So let's click that. And then I hit submit again. We get a little clearer picture of what's going on. It doesn't take long for Newton's method to be successful. On the other hand, if you remember, this graph has a few x-intercepts. If I go back to zoom standard, Z standard, we see it has an x-intercept here, and here, and here. Well, what if I wanted this one right here? So the first thing I want to do is get an idea of where it is. If I go to trace, then I can trace along the curve and say that it's somewhere around x equals about 1.6, maybe 1.5. So now what I'm going to do is I'm going to go to my guess and make that 1.5. And if I hit submit now it starts at the guess 1.5, and that'll find the root that we're interested in, which looks like it's about 1.665 or so. Doesn't take long, again, for Newton's method to find it, if Newton's method works. Okay, let's try Newton's method for our own creative graph. Let's suppose we wanted to find the square root of 2. Now, the square root of 2 is a solution to the equation x squared minus 2 equals 0. So I can go to my equation, and I can type in x squared minus 2. And a first guess might be at x equals 1. And now if I hit submit, we'll see it quickly approximates the square root of 2. And the square root of 2 really is about 1.4142136. What if instead we accidentally guess 0? What would happen? Well, notice at 0, the tangent line to that graph is horizontal. And the tangent line does not cross the x-axis. So let's type in 0 for our guess and just see what happens. We hit submit, and it just says fail. So Newton's method fails if our first guess had been x equals 0. If we wanted the other solution to x squared minus 2, then we could say guess at x equals negative 3, for example. And I hit submit. And there we have it. The other solution to x squared minus 2 equals 0 is negative 1.414, etc. So notice if we wanted to keep going, we could type in negative 1.4142136. as our first guess and hit submit, and basically we're starting right near the root, and it will verify that this really does stay at negative 1.414213.6. So if you're not close enough to the root, you can always type in x6 and get closer. So that's about all I have to explain Newton's method. So hopefully you'll figure this out. Otherwise, send me an email at drlarrygreen@gmail.com, drlarrygreen@gmail.com.